Hello viewers, welcome to BakoMaths. And today's lesson, we'll be looking at how to calculate the Spearman's rank correlation coefficient for 3 data sets. And this is a clear example. So in the question, we can see a table, and the table consists of candidates which start from A and ends as J. Now, these candidates were examined by 3 examiners, and candidate A obtained 90 marks from examiner 1. Candidate B obtained 88 marks from examiner 1. Candidate C obtained 71 marks from examiner 1. To the last candidate J, who obtained 14 marks from examiner 1. Candidate A again obtained 89 marks from examiner 2. Candidate B obtained 92 marks from examiner 2. Candidate C obtained 70 marks from examiner 2. To the last candidate J, who obtained 60 marks from examiner 2. Again, candidate A obtained 88 marks from examiner 3. Candidate B obtained 89 marks from examiner 3. And then C, candidate obtained 71 marks from examiner 3. To the last candidate J, who obtained 50 marks from examiner 3. Now, this is the meaning of the table here. Now, the question says that we should calculate the Spearman's rank correlation coefficient of the marks awarded by examiners 1 and 2, examiners 1 and 3, and examiners 2 and 3. B part says that use your results in A to determine which of the examiners agree most. Mostly, we calculate the Spearman's rank correlation coefficient for 2 data sets, and here is the case we have 3 data sets. So we can still continue by the normal procedure by drawing a single table for the data set and then deducing the ranks and the differences, which will lead to the calculation of the Spearman's rank correlation coefficient. So we draw a table as such. So this is our table here, and we can see that the question consisted of candidates which started from A and ended at J. So it means that there were 10 candidates. Now, we are going to rank the values obtained by each candidate from the examiners. So it means that ranking the values from examiner 1 will now give us here as rank 1. Ranking the values obtained by each candidate from examiner 2 would have rank 2 here. Ranking the values obtained by each candidate from examiner 3 will give us rank 3. Now, we go back to the question and rank the values. Later, we come and transfer them here in this table. So we have here. So for examiner 1, looking at the row for examiner 1, we can see the values 90, 88, 71 to the last value 14. So the ranking goes this way. The highest number will take the first rank, followed by the next highest number, which will take the second rank, to the least number or lowest number, which will take the last rank. So looking at the values for examiner 1, we can see that 90 is the highest number. So since the highest number, it will take rank 1. So that will be rank 1. And then we can see that 88 is the next highest number, which will take rank 2. We can also see that 72 is the next highest number, which will take rank 3. And then we can see 71 to be the next highest number, here to have rank 4. We can also see that 70 is the next highest number, which will take rank 5. We can also see that 65 is the next highest number, which will take rank 6. And then 41 is the next highest number, which will take rank 7. We can also see that 38 is the next highest number, which will take rank 8. And then 32 is the next highest number, which will take rank 9. And then the last number, which will take the last rank as 10. So being able to rank them, we go back and transfer the same ranks of values in our solution. So from the ranking, realize that candidate A took the first rank. That was 90, which means we write 1 here. And then candidate B was ranked as the second. Candidate F had the third rank, so write 3. Candidate C had the 4th rank, so write 4. Candidate G had the 5th rank, so write 5. Candidate D had the 6th rank, so we write 6. Candidate H had the 7th rank, so we write 7. Sorry. Candidate I had the 8th rank, so we write 8 here. Candidate E had the 9th rank, so we write 9 here. And then candidate J had the 10th rank, so that is 10. So being able to write this, now you go back to examiner 2 to rank 8 values, and then we come and transfer just like we did for examiner 1. So now we rank the values for examiner 2. So we come back and then we could see that the highest number here among the values for examiner 2 is 89. Sorry, it's 92 instead, which will take the first rank as 1. So you write 1 here. You write 1. And then the next highest number here is 89. So you write 2. Now the next highest number is 72, of which you write 3 here. That's the 3rd rank. Now the next highest number, let's circle so that we can differentiate among them. So the next highest number here is 70. That's the 4th rank. Now the next highest number here is 68. That's the 5th rank. The next highest number here is 66. That is the 6th rank. The next number is 40. That is the 7th rank. The next number is 39. That is the 8th rank. So 39 is the 8th rank. The next number here is 35. That is the 9th rank. And then we can see that the 10th rank here is 16. So we've been able to rank them. We just go to the next table, our solution, then write the table of values for it. So for rank 2, 8 values here are, so we could remember that B took the first rank, so B will now have 1, follows on to A, that was 2, and then we can see that G was the 3rd. You can remember that C was the 4th. You can remember that D was the 5th. That was, and then F was the 6th, so we write 6 here. And then we can see that I was the 7th, so we write 7 here. Now H was the 8th, so we write the 8th position for it. And then E was the 9th, so we write 9 here. And then J was the 10th, so we write it. Now we go back to our question again and rank examiner 3. So for examiner 3, we can identify the highest number here as 89. That's for candidate B. So it means that candidate B was the first rank, so we write B for it. Sorry, we write 1. So we write 1 here. And then we can see that 88 is the 2nd, so that is 2. And then C is the 3rd, that is 71 is the 3rd, that gives us 3. And then we can also see that 69 is the 70 is the 4th, so we write 4 here. And then we can see that 69 is the 5th. We can also see that 67 is the next, that is the 6th. And then 39 is the 7th. And then 38 is the 8th. That's the 8th rank. And then you can also see that 36 is the 9th rank. And again, 15 is the 10th rank. So we go to our solution and write the same values for it. So we can clearly remember that for examiner 3, B was the first rank, candidate B was the first rank, so we write 1. And then A was the 2nd rank. And then we can see that C was the 3rd rank, so we write 3. You can see that F was the 4th rank, so we write 4. You can also remember that G was the 5th rank, so we write 5 here. And then we can see that D was the 6th rank, so we write 6. And then I was the 7th rank, so we write 7. And then H was the 8th rank, so we write 8 here. Now E was the 9th rank, so we write 9. And then J was the 10th rank, so we write 10. Now we have this. So after getting the ranks, the next step is to find the difference and square. So it means that you have to find the difference for examiner 1 and 2, taking into consideration their ranks, find the difference for examiner 1 and 3, and then square, find the difference for examiner 2 and 3 and square. So for the first one, that is the difference for examiner 1 and 2, which is given by R1 minus R2 is this. And then after getting the difference, we square. We do another table for the square of D. But in this case, it will be long, so we can make it easy by squaring it right away. So that gives us D squared, and then we now have R1 minus R2 squared. And then we continue for the next one, that is D of the difference of examiner 1 and 3, that is examiner 1 and 3 with respect to their ranks, which will give us R1 minus R3, and then we also square that one too. So that gives us D squared here. And then the third one will be the squared of 2 and 3, which is equal to the difference between R2 and R3, and then we square. So now we have it. So we look at the ranks 1 and 2. When you subtract, 1 minus 2 gives us -1, and the square of -1 gives us 1. And then 2 minus 1 gives us 1. The square here is 1. 4 minus 4 is 0. So when you square 0, we get 0. 6 minus 5 is 1. The square of 1 is 1. 9 minus 9 is 0. The square of 0 is 0. 3 minus 6 is minus 3. But the square of minus 3 is 9. 5 minus 3 is 2. The square of 2 is 4. 7 minus 8 is -1. The square of -1 is 1. 8 minus 7 is 1. The square of 1 is 1. 10 minus 10 is 0. And the square of 0 is 0. That is for the difference for rank 1 and 2. Now go to the difference for rank 1 and 3, and then we square. So that is 1 minus 2 gives us -1. The square of -1 is 1. 2 minus 1 is 1. The square of 1 is 1. 4 minus 3 is 1. The square of 1 is 1. 6 minus 6 is 0. And the square of 0 is 0. 9 minus 9 is 0. The square of 0 is 0. 3 minus 4 is -1. And the square of -1 here is 1. 5 minus 5 is 0. The square of 0 is 0. 7 minus 8 is -1. But the square of -1 is 1. 8 minus 7 is 1. The square of 1 is 1. Now 10 minus 10 is 0. And the square of 0 is 0. We continue, find the difference and squaring for the rank 2 and 3. So 2 minus 2 is 0. The square of 0 is 0. 1 minus 1 is 0. The square of 0 is 0. 4 minus 3 is 1. The square of 1 is 1. 5 minus 6 is -1. The square of -1 is 1. 9 minus 9 is 0. The square of 0 is 0. 6 minus 4 is 2. But the square of 2 here is 4. 3 minus 5 is 2. The square of 2 is 4. 8 minus 0 is 0. The square of 0 is 0. 7 minus 0 is 0. And the square of 0 is 0. 10 minus 10 is 0. And the square of 0 is 0. So now we have this. What is left is to find the summation of the differences. That's the square of the differences. So for difference of 1, 2, now the summation, that is sigma d squared 1, 2. When we sum all the values here, we get an answer of 18. In the same way, when we find the summation of 1 and 3, we get an answer of 6. When we sum that of 2 and 3, all the values here gives us an answer of 10. So that is the sigma of all the respective. So now that we have all the values figured out, we can now calculate for the Spearman's rank relation coefficient for the respective examiners, just as demanded by the question. So we go back to the question. And the question said that calculate the Spearman's rank relation coefficient of the marks awarded by I examiners 1 and 2, and II examiners 1 and 3, also examiners 2 and 3. So you have to calculate for the Spearman's rank correlation for each of the examiners here. Now we come back and we can recall that the formula for the Spearman's rank correlation coefficient is giving us 1 minus 6 sigma d squared divided by n into bracket n squared minus 1. So this is the formula we're going to use in calculating for the Spearman's rank correlation coefficient for the examiners. So remember that we said to calculate for the Spearman's rank for examiner 1 and 2, and since we are combining the two examiners here, our formula now becomes 1 minus 6 sigma d squared of, so difference squared of the examiners 1 and 2 divided by n to bracket n squared minus 1. But we can remember that the candidates here are 10, that is from A to J, sum up to 10 candidates, which means n is equal to 10. Now that we have it, we now proceed with our Spearman rank correlation for examiners 1 and 2 as R of 1, 2, which is equal to 1 minus 6. Now the summation of d squared with respect to examiner 1 and 2 is, it was giving us what, 18. So we go back and substitute the value here. So we have into brackets 18, all divided by, we also remember that our n is 10. So we do that substitution here. So that gives us divided by 10 to bracket 10 squared minus 1. So further simplification gives us 49 on 55. So the Spearman rank correlation coefficient for examiner 1 and 2 is giving us 0.8908. So to 4 decimal places, this is the Spearman rank correlation coefficient for the examiner 1 and 2. We proceed to the second one, that is the Spearman rank correlation coefficient for examiner 1 and 3, of which that is given by the R of 1, 3, which is equal to 1 minus 6 sigma d squared of 1, 3 divided by n squared minus 1. So the R of 1, 3 is equal to, so when we substitute 1 minus 6 multiplied by the summation of d squared 1, 3 from the table, we said is 6. So you come and substitute the value respectively, divided by 10, and then we have 10 squared minus 1. So our R of 1, 3 is equal to, in its simplified form, gives us 53 on 55. So when we simplify, we should get 53 on 55. So we have here as 53 on 55. So in decimal, our R of 1, 3 is equal to 0.9636. We continue to the third rank correlation coefficient for examiner 2 and 3, of which we are going to have 1 minus 6, the summation of the difference squared for examiner 2 and 3, all divided by n squared minus 1. So substituting gives us 1 minus 6, and the summation for examiner 2 and 3 with respect to their difference squared, here we had 10. So we go back and substitute, have our 10 here, divided by, so our n is 10, that is 10 squared minus 1. So the R of 2, 3 in simplified form gives us an answer of 31 on 33. So writing this in decimal gives us our R of 2, 3 to be equal to 0.9394. So A is answered for this question. So this is how you can find the Spearman's rank correlation coefficient for the examiner 1 and 2, the examiner 1 and 3, and examiner 2 and 3. Now the question follow up with a B, that is, use your results in A to determine which of the examiners agree most. So based on the values we had for the respective examiners, that is the Spearman rank correlation coefficient for examiner 1 and 2, 1 and 3, and 2 and 3, we are going to base on it to identify which of the examiners agree most. We can do that by looking at the interpretation of the Spearman rank correlation coefficient, which is, if we have any R value of which we know our R to be the Spearman rank correlation coefficient, and then the R value lies within 0.0 to 0.2, we can determine that R as, or we can determine that correlation coefficient as a very weak correlation. If our R lies within 0.2 to 0.4, we can determine that Spearman rank correlation coefficient as a weak correlation. And then if R also lies within 0.4 to 0.7, it's determined as moderate correlation. If it lies between 0.7 to 0.9, a strong correlation. If it lies within 0.9 to 1.0, it can be termed as a very strong correlation. Now we go back to look at the values and see where they lie. So for the first value, the first R value, that is 0.8908, we can see that it will lie within this range, that is 0.9 to 0.7 to 0.9. So that is a strong correlation. So beside it, we can write strong correlation. So that is SC. Let's write SC for strong correlation for examiner 1 and 2. Now let's go back to the next one, that is 0.9 to 0.963. So following the same procedure, we can interpret the correlation coefficient for examiner 1 and 3, and that was found to be 0.9636. So going back to the correlation coefficient range of values, that is, we can see that lies within 0.9 to 1.0, and that can be termed as a very strong correlation. So beside the value of examiner 1 and 3, we now write VSC, indicating that it's a very strong correlation. Now we do same for examiner 2 and 3, and their rank correlation coefficient was found to be 0.9394, of which we can interpret that as very strong correlation because it lies within the range of 0.9 to 1.0. So beside 8 value, that is for the rank correlation coefficient for examiner 2, 3, we can also write VSC, indicating that it is a very strong correlation. Now it says that use your result in A to determine which of the examiners agree most. So we can see that to determine the examiners that agree most, we can see that it's going to base on the rank correlation coefficient for examiner 1, 3 and that of examiner 2, 3, because they are those that their range of values agrees very strongly. Now we are going to ignore examiner 1, 2 for now. We are going to ignore this for now and draw the emphasis on 1, 3 and 2, 3. So we can see that for examiner 1, 3, the Spearman rank correlation coefficient value is 0.96. So let's take it from the first 3 values. So after the decimal point, the number that follows here is 96. That is for examiner 1, 3. When you come to examiner 2, 3, we can see that its value here is 0.93. So after the decimal point is 93. So comparing these two values, we can see that the value for examiner 1, 3 is bigger or larger than examiner 2, 3. So based on that, we can see that examiner 1, 3 agree most as compared to the other two, because looking at it, it has the highest value as compared to the rest, and then it also agrees strongly, very strongly, just as examiner 2, 3 agrees very strongly. But by comparing the values, we can see that the examiner 1, 3 has a higher value of 0.96 as compared to the examiner 2, 3, which has a value of 0.93. So therefore, we can say that in answering B, we can say that the examiner or the examiners 1 and 3 agree most. So based on the analysis we just drew, we can say that 1 and 3 agrees most. So this is all about today's video, and I believe you made the best out of it. So thank you for watching. This is BakoMaths. You are thinking beyond infinity. Kindly like, comment, subscribe, and share. See you in our next video. It's bye bye for now.